Hello, my name is Jesse Morrison. I'm a biological engineering student at the University of Arkansas-Fayetteville, and today I will be discussing my ongoing study of the white-tailed deer population of Hobbs State Park. The purpose of this project is to gather data that will help Hobbs to manage their deer population. This will help the park to take action to control the impact of events that lead to population decline, such as overhunting, the spread of disease, invasive species, and weather events. Controlling overpopulation is also important to prevent environmental harm, starvation, and accelerated disease spread. These issues are especially important with the rise of hogs throughout Arkansas and the spread of chronic wasting disease. The rangers and volunteers of Hobbs have conducted many spotlight surveys over the years. Some of the data and trends from these previous surveys can be seen in the graphs below. These surveys measured the amount of deer that were spotted, but there was no method of estimating the number of deer that were not spotted, so I have recommended a distance sampling approach. Surveys will begin this week, 30 minutes after sundown during the new moon when deer activity peaks. Volunteers will drive slowly along selected routes on this map and count deer, as well as measure the distance to deer using laser rangefinders. I will use the number of deer and the distance to each deer to estimate the deer population in roadside habitats throughout the park. A distance sampling approach involves finding the frequency of sightings at different distances from the viewer and using this to estimate the number of deer that were not spotted. In this example, the gray line represents a road and the red dots represent deer sightings. The example data shows that at a higher distance from the viewer, there are fewer sightings. Presumably, all deer just next to the road will be spotted, but further away, foliage or terrain could prevent a sighting. By graphing the number of deer spotted at different distances, the probability of a deer sighting can be estimated. If the deer density is random in relation to the roads, if the deer do not move much to avoid surveyors, and if enough habitat is sampled, the actual average deer distribution should be similar at different distances from the viewer. Since not all of these deer are seen, we can use this graph to estimate the proportion of hidden animals and estimate the total roadside population at Hobbs. Some of the assumptions I stated are a bit difficult. Deer are not necessarily randomly distributed in relation to roads, and this may cause some bias. Roads alter a habitat and alter deer behavior. For this reason, I'm only going to be able to reliably estimate the roadside population of deer at Hobbs. This, however, will probably be a large proportion of the population, and it will help the park monitor changes in the deer population in the future. Despite potential bias due to using roads, I have recommended this method to the park since it is convenient and repeatable for such a large park. Using roads will also allow for more data collection since more ground may be covered and deer are less likely to avoid cars than surveyors on foot. This will help uphold the assumption that the deer are not moving further from the transect to avoid surveyors. Thank you for viewing my presentation. I would like to thank the University of Arkansas for providing me with an honors research grant to fund this project. I would also like to thank the STEM posters at the Capitol event for hosting my presentation. Have a nice day.